Okay, so today's video is going to be on the volume of solids of revolution in the washer method. And the washer method is usually used when you're trying to find the area between two curves. So to start off, let's first describe what a washer is. A washer is basically it resembles what a washer is like in a toolbox. It's this big circle with a smaller circle, and it's this area. This is the area that we use in a washer method. And it has an outer radius and an inner radius, where the inner radius is the smaller one and the outer radius is the larger one. So if we have the example, calculate the volume between the curve y equals x squared and y equals x rotated around the x-axis, the first thing we want to do is kind of visualize what we're doing. So let's draw a graph. So if we have our coordinate plane, we know that the graph of y equals x squared looks something like this for x greater than 0. Let's draw that again. And that's still a bad drawing. Okay, like that. And that y equals x looks something like this. Okay, that's much better. And this region is what we're rotating around the x-axis. And the way we rotate it, quote unquote, is we basically mirror it against the x-axis. So I'm going to do just that. I'm going to draw y equals x squared in my blue, y equals x in my pink. And then let me just erase this really quickly. Oopsies. And then we can draw in our washers. So the way our washers are going to look is we're going to have our big outer radius and then our thinner, smaller inner radius. So this might be a better example. Our big outer, and our thinner inner radius. So we can have multiple washers just like that. So the first thing we want to do in solving these questions is we have to realize that volume is just the integral of area. And it's much easier to find area. So the way we find the area is, okay, the first thing we want to do is find the inner radius. So the inner radius is always just the radius closer to the x-axis, or in any question, the axis that you're rotating around, which is the x-axis in our case. So if we look at it, x squared is closer to the x-axis than is y equals x. So that's our inner radius. Then we have to define our outer radius, which is the one further away from the x-axis. So as we can see, y equals x is further away from the x-axis. So once we define our inner radius and outer radius, we find the area. So if you remember, a washer is the area of the big circle minus the area of the smaller circle, leaving the washer area as a remainder. So we're going to do the same thing. The area of the big circle, which is pi times x squared, where x is the radius of the big circle, minus the area of the smaller circle, which is pi times x squared, where x squared is the radius of the smaller circle. And when we simplify that, we get pi times x squared minus x to the 4th. So this is our area of one washer. So now all we need to do is find the integral of the area to get the volume. So we're going to do just that. And the integral of the area ends up equaling 2 pi over 15. So that is our volume. So that's it. Those are all the steps you need to do. This is a very simplified version of how to find volumes of solids of revolution using the washer method. Thanks for watching.